We've talked at length about global-scale processes, how lithospheric plates move and interact with one another, the theory of plate tectonics. Now I'd like to introduce you to Tanya Atwater, Professor of Geophysics at the University of California in Santa Barbara. Professor Atwater is one of the pioneering researchers who deciphered a significant piece of the story of how plates interact. Tanya?
I was just starting my scientific career when all these things were being figured out, and it was such an exciting time. Everything on Earth was waiting to be reinterpreted and refigured out in light of the new theories. I was working in California, and naturally I began thinking about the San Andreas Fault. And I was also working in the offshore geology history, and it turns out the offshore has the key to understanding how the San Andreas came to be. So let me show you what I figured out. About midway through the Cenozoic era, the infamous San Andreas Fault was born. We've already learned Andreas is a strike-slip fault, but it turns out that it's also a very long transform fault. In fact, it's the present-day plate boundary between the North American plate and the Pacific plate. Let's take a look at how this plate boundary came to be. If we could look down from outer space 50 million years ago, here's how the plates would have looked. At that time, a spreading ridge lay offshore of western North America. The jagged red line is the spreading ridge. That ridge was a Pacific plate and an ancient plate we call the Farallon plate. The Farallon plate was spreading away from the Pacific and was diving beneath North America along a subduction plate boundary. That's the smooth line along the continental edge. Notice how the mid-ocean ridge came ever closer to North America. About 25 million years ago, the spreading ridge entered the subduction zone. At that time, the Pacific plate made its first contact with this part of North America, and a new plate boundary was formed between them. This fault was born. If we take a closer look, we can see how the San Andreas Fault formed and developed as the spreading ridge system was gradually subducted. Notice that when the spreading ridge first entered the subduction zone, the old Farallon plate broke in two pieces. The new plate to the north we call the Juan de Fuca plate. The remnant to the south was to become the Cocos plate. The Andreas plate boundary connects the Juan de Fuca spreading system at its northern end with the Cocos spreading ridge at its southern end. As more and more of the spreading ridge was subducted, the San Andreas transform plate boundary grew and grew, slowly acquiring the great length we know today. Let's view the sequence again and try to notice three things: the birth of the San Andreas Fault, the lengthening of the fault system, and how the San Andreas plate boundary always broken ends of the old spreading ridge. This time, notice when Baja California became attached to the Pacific plate and was ripped away from the rest of Mexico. This pulling away caused a new spreading system to form and to create the new narrow ocean that we call the Gulf of California. Now let's place the San Andreas Fault story into a human context. Let's see how the locations of 4 modern-day cities were affected by the San Andreas plate boundary over the last 20 million years. Ones of San Francisco, Santa Barbara, Los Angeles, and San Diego. What is now the coastal town of Santa Barbara was once quite close to San Diego, and San Francisco was much farther south than it is now. As the San Andreas system developed, San Francisco and Santa Barbara broke off first and were carried up the coast by the Pacific plate. Later, Los Angeles and San Diego broke off and followed them. We'll play this animation one last time and we'll pose a question. This time, notice that the plate boundary deformation wasn't just confined to the San Andreas fault line. All of western North America was affected by the plate interaction. Let's focus on the state of Nevada. What happened to Nevada as time went by? Here's a hint. Nevada is now all broken up by faults. What kind of faults do you think those are? Strike-slip faults? Normal faults? Faults. What do you think?